Mathusay. Good day everyone. Welcome to Yan Ang Mathusay. I am Teacher Yan. For today's lesson, we are to learn about special products, specifically on the difference of two squares. Are you ready? Let us have first a simple recall. Can you still remember the product rule of exponent? The product rule of exponent tells us that when multiplying two powers that have the same base, we copy the base and other exponents. We have to remember this pattern. X raised to m times x raised to n is equal to x raised to the sum of m and n. In this example, you can see how it works. X raised to 5 times x cubed is equal to, applying the rule, copy the base x, and then add their exponents. And it will result to x raised to 8. X times x. Here, as you can notice, our exponents are not visible. We have to copy the variable x. When our exponents are not visible, that would mean our exponent is equal to 1. Get the sum of their exponents. The answer is x squared. Can you try this one? Alright, you have to apply the rule. You have to copy x and then get the sum of their exponents. Very good. The answer is x raised to 7. And now, let us first define what do we mean by difference of two squares. When the sum and the difference of a binomial are multiplied to one another, the product is the difference of the square of the two terms, as in, the quantity of x plus a times the quantity of x minus a is equal to x squared minus a squared, where x is a variable and a is a constant number. Let us now solve the following binomials. The quantity of x minus 5 times the quantity of x plus 5. We have the quantity of 2x minus 7 times the quantity of 2x plus 7. Another one, we have the quantity of 8x plus y times 8x minus y. When we multiply binomials, we have to remember to use your FOIL method. FOIL method is an acronym that stands for first, outer, inner, and last. That makes your FOIL method. The quantity of x minus 5 times the quantity of x plus 5. Applying now the FOIL method, let us first multiply our first terms, x times x. Next, our outer terms, x times positive 5. Then, our inner terms, negative 5 times x. And last, our last terms, negative 5 times positive 5. Then we simplify. So we have x squared plus 5x plus negative 5x minus 25. Resulting to x squared plus 0x minus 25. Notice that our linear term, which is 0x, the numerical value, the numerical coefficient is equal to 0, which means it has no value. Our final answer now becomes x squared minus 25. For our next example, we are to multiply the quantity of 2x minus 7 times 2x plus 7. First, we will multiply our first terms, 2x times 2x. Next, our outer terms, plus 2x times 7. Next, our inner terms, plus negative 7 times 2x. Then, our last term, plus negative 7 times positive 7. Then we simplify. We have 4x squared plus 14x minus 14x minus 49. Here, our linear term or our middle term can be cancelled out. And our final answer is 4x squared minus 49. Let us take a look at this example, the quantity of 8x plus y times 8x minus y. Same rule applies, 8x times 8x, our first terms, that is equal to 8x times 8x. Then our outer terms, we have plus 8x times negative y. Our inner terms, we have plus y times positive 8x. And our last term, we have positive y times negative y. Simplify, we have 64x squared minus 8xy plus 8xy minus y squared. Here, our middle term is being cancelled out. And our final answer is 64x squared minus y squared. It's your turn now. You solve the quantity of 9x plus 8 times 9x minus 8. Quantity of 9x plus 8 times 9x minus 8 is equal to, first terms, 9x times 9x. Outer terms, we have plus the quantity of 9x times negative 8. Inner terms, we have plus 8 times 9x. And our last terms, we have plus positive 8 times negative 8. Simplify, we have 81x squared minus 72x plus 72x minus 64. The middle term will be cancelled out. And our final answer is 81x squared minus 64. Your turn. Here's another one. Solve the quantity of 4x minus 15 times 4x plus 15. The quantity of 4x minus 15 times 4x plus 15 is equal to, first terms, we have 4x times 4x. Outer terms, we have 4x times positive 15 plus 4x times positive 15. Our inner terms, we have plus negative 15 times 4x. And our last terms, we have negative 15 times 15. So, plus negative 15 times 15. So, simplify, we have 16x squared plus 60x minus 60x minus 225. Our middle term is being cancelled out. Final answer is equal to 16x squared minus 225. Let us take a look again at the given examples and study the pattern. When the sum and the difference of a binomial are multiplied to one another, the product is the difference of the square of the two terms. Here, in the given example, we have the quantity of x minus 5 times the quantity of x plus 5. Following the pattern, we have to square the first term, which is x squared, and then copy the negative sign, and then square the second term, which is 5 squared, that is 25. So we have x squared minus 25. In the second example, we have 2x minus 7 times 2x plus 7. Square the first term, which is the quantity of 2x, that becomes 4x squared. And then copy the negative sign, square the second term 7 squared, that is 49. So we have 4x squared minus 49. In the third example, we have the quantity of 8x plus y times 8x minus y. Square the first term, we have the quantity of 8x squared, that becomes 64x squared. Copy the negative sign and then square y, that becomes y squared. So our final answer is 64x squared minus y squared. Try to solve the following difference of two squares and post your answers on the comment section. For our next lesson, we will learn about square of binomials. Thanks for watching. For more Yan Ang Mathusay lesson episodes, please don't forget to click like, subscribe, and hit the bell button and share. Again, this is Teacher Yan. See you on our next lesson.